Pleasant morning to one and all. I'm Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. I'm here to present you about the Java threads. A thread in Java, a thread is a lightweight process uh, that enables a multitasking within a program. The thread allows a concurrent execution of a task, improving the performance and responsiveness in application. The Java supports a multithreading, where a multiple threads executes independently, sharing the same memory space. The Java virtual machine manages a thread, enabling an efficient execution of a task. Creating a thread in where it provides us extending the thread classes like class of my thread extends a thread and public void run of system.out.println with a thread is running and public static void main string of args and my thread t1 is equal to new thread of t1 dot start starts a thread and so on. The run of method contains a code that executes in a separate thread and start of method initiates a new threads and invoke the run of. Implementing the runnable interfaces, the class of runnable implements your runnable public main void main of system.out.println. The runnable thread is running and where the public static void main with a string of r thread of t1 is equal to new thread of new runnable and t1 dot start of. Implementing the runnable is preferred when extending other classes. The runnable interfaces ensures a better separations of concern. We have the implicit threading where the thread life cycles goes with the following states during the executions of new runnable blocked waiting timed waiting and terminator. New is where it created but not started. The thread t1 is equal to new thread of and runnable is ready to run waiting for the cpu t1 dot start of. Blocked is where waiting for a resources, example blocking an object, and waiting is indefinitely waiting for another thread signals. The timed waiting is where the waiting for the fixed time sleep of join of. The terminator is where the execution completions are aborted. The important thread methods we call method of descriptions. Start off is being a thread execution and run off contains a thread's execution logic and sleep off is where passes execution for ms milliseconds and join off makes a current thread waits until another finishes. Is alive is where it checks if the thread is still running and set a priority is where it's setting a priority from 1 to 10. Yield of method is just suggest gives a cpu to another thread. This was an open MB where the thread synchronizations will exist when a multiple thread access a shared resources. Race conditions may occur, and this synchronization prevents a data inconsistency by allowing only one thread at a time to access the resources. Using a synchronized method, we can have class of shared resources with a synchronized void print number of and for int phi is equal to 1 and I is less than or equal to phi I plus plus. The system.out.println with a thread dot current thread of dot get name of class my thread extends a thread. So this synchronized keyword which always ensures only one thread access to print of number method at a time. So the grand central dispatch is where using a synchronized block, the synchronizing a block instead of the entire method improves your performance. And here comes a deadlock. The deadlock and how to prevent them. The deadlock occurs when two or more threads waits indefinitely for each other to release the resources. And the basic example of the deadlock is where the thread communicates while using a wait notify and notifying all. Class of shared resources block and flag is equal to false. Synchronized void produce of through the interrupted inception while flag of wait of the system.out.println.produce and flag is equal to true, notifying that synchronized void consumes through interrupted exception, while flag of wait of and the system.out.println consumed. Flag is equal to false when notifying with the fork and executions. So hence a thread enables a concurrent programming, improving the performance and responsiveness. The proper use of synchronizations and the communication and deadlock prevention ensures efficient multi-threading. Mastering these concepts is essential for developing a scalable and high performance applications in Java. I hope you're clear with this concept. Thank you.